Exercise 2.4, question number 1a. If A complement union B is U is the universal set, then prove that A is the subset of B. So, see, given A complement union B is U, so I have taken complement in both sides. A complement union B whole complement is equals to U complement. Now you see, it is equals to A complement whole complement intersection B complement. This is De Morgan's law. Now you see De Morgan's law. I have told it about De Morgan's law. See, this is A union B complement equals to A complement intersection B complement. So these things should be known to you before doing this sum. So you see, this is A dash union B whole complement, A complement intersection B complement, and U complement is phi. We know about it. Now you see, A complement is here nothing but A, isn't it? Intersection B complement is equals to phi. Now you see, this is A intersection B complement is equals to M minus B. This should be known to you as a formula. Okay, remember this. So this is used here. A intersection B complement equals to phi. This implies A minus B is equals to phi. If A minus B is equals to phi, then it means what? All the elements in the set A are present in the set B. Okay, A minus B is equals to phi. Suppose elements in A 1, 2 and elements in B also 1, 2, then and only then A minus B is equals to phi, isn't it? So all the A minus B equals to phi means all the elements in the set A are present in the set B. That means what? A is the subset of B. Proved. First problem proved here. Now the second one is, if A is a subset of B, then prove that B dash means B complement is a subset of A complement. Okay, let us take X as is an element of the set B complement. Okay, now that means what? X belongs to B dash. This implies X not belongs to B. This implies X not belongs to A, because A is the subset of B given. Now X not belongs to A, that means X belongs to A dash. A dash or A complement means U minus A. So this say X belongs to B dash and X belongs to A dash, that means B is the subset of A dash. This is proved here. Question number 1ac. If A minus B is equals to phi, okay, you have to prove if and only if A is a subset of B. Now A minus B is equals to phi, that means what? A intersection B complement is equals to phi. Means I told you, no, that A minus B is equals to A intersection B complement. As a formula you should know this. Now you see, A equals to A intersection U. U is the universal set and A intersection U is nothing but your A. Okay, now A intersection B union B complement is your U. Okay, B is any set. Now A intersection B union B complement is your A complement B union A intersection B, this union A intersection B complement, and A intersection B complement is your phi. So this is phi. Now A intersection B union phi is your nothing but A intersection B. So A is equals to A intersection B. Okay, now this means what? A intersection B is your A, nothing is, that means what? A is the subset of B. 1d, question 1ad. If A minus B is equals to A, if and only if A intersection B is equals to phi. Now you see, given this, okay, you have to prove that A intersection B is equals to phi. So if A minus B is equals to A, that means what? Not a single element of A is present in the set B. Okay, then and only then A minus B equals to A is possible, and not a single element of A is present in the set B. That means A intersection B must be equals to phi. This is what you have to prove. Again you see, if A intersection B is equals to phi, we have to prove that A minus B is equals to A. So A intersection B is equals to phi means set A and set B have no common element. then also a minus b is equals to a. This is proved here. Now question number 1ae. If a union b is equals to a, then b is the subset of a, and conversely, means you have to prove, given if this is given, you have to prove this, and this is given, you have to prove this. This means, so given a union b is equals to a, let x belongs to b and x belongs to b or x belongs to a. That means I can write this line after this because it doesn't change any meaning. Okay, now x belongs to b union a, this or is there, no, that means b union a and a union b are same thing, and given a union b is equals to a, so x belongs to a union b means x belongs to a, and x belongs to b we have taken before, so x belongs to b and x belongs to a, that means b is a subset of a. Again, given, now you have to prove this conversely, b is the subset of a, you have to prove a union b is equals to a. Now you see b is the subset of a, let x belongs to a union b. Now this means x belongs to a or x belongs to b, x belongs to a or x belongs to a, because this is given b is the subset of a, so I can write it like this. So x belongs to a union or, no, so a union b, so a union a, that means x belongs to a, so I can write a union b is equals to a. Now you remember this sign, this is not implies, because if I start from here I can get this value, if I start from here I can get this value, so inverse is also true. So you always use this sign in sets whenever you do this kind of proof. So this is proved here. And question number 1e, e done, and f is similar to this, you just try it at home. This is your homework.